So hopefully you've watched my introduction to the negative law, or the negative indices law, and I'm now going to move on from that. So I'm going to just remind you that this was the rule that we came up with, which basically says that you use the base, and if you see the negative power, then it's 1 over the base with the power as a positive. And I did say there's some deviations, so we'll look at a few examples and look at what happens when the base is a fraction. So let's turn 5 to the negative 2 into a positive index. So following the general rule above, it's telling me the base is 5, the power is negative, so therefore it's automatically 1 over, and then the fact that it's 5 to the power negative 2 tells me that that positive power becomes 5 squared. If you're asked to evaluate that, clearly it would be 1 over 25. And usually we would write that because we're dealing with quite a low power and it's easy for us to evaluate 5 squared. So 5 to the negative 2 is equivalent to 1 over 5 squared, which of course evaluates to 1 over 25. Let's look at a pronumeral, x to the power negative 6. So following our general rule, we know that we do 1 over x to the power 6. So let's have a look at what happens when it's a fraction. So let's imagine we've got 3/5 to the power, and let's make the power negative 1 for a start. Well, we've got here powers of 1 inside here. This is just 3/5, so technically that's 3 to the power 1, that's 5 to the power 1. And there are various ways of you looking at this. You could automatically substitute the rule in, or you can follow the fourth law of indices, which means you can raise this power to a further power on each the numerator and the denominator, and then have a look at what those negative powers mean individually. There is no right answer. You can choose whichever you would like. I'm going to go with this, following this rule here. So this becomes 1 over 3/5, because that's what our base is. But we don't write it like that because we're dealing with 1 divided by a fraction. And when we're doing that, we can also write it like that. And we know that the division means that we do the reciprocal. We flip that second fraction and we get 1 multiplied by 5 over 3, which is just 5 over 3. Now let's have a look at what we've got here. It was only to the negative 1. So 1 is the positive power, which was on the denominator. And what you can see is the fraction has pretty much just flipped to give us our result. We call this the reciprocal. Okay, so let's have a look at when this power isn't negative 1, say negative 2. Let me just clear some room. Okay, so sticking with the same fraction, I'm going to do 3/5 to the power negative 2, and I'm going to follow the same procedure. So we've got 1 over 1 divided by, because remember over means divide, 1 divided by 3/5. And I'm using the power of a power law. It's actually, the positive would be 2 power 2. So it's 1 divided by 3 squared over 5 squared. So I'm going to just evaluate that in a moment. I'm going to do my multiplying 5 squared over 3 squared, which gives me 5 squared over 3 squared, which is this flipped, isn't it? So let's evaluate that because we're dealing with easy numbers. 5 squared is 25, 3 squared is 9. 25 over 9 is an improper fraction. Do some further examples now. Well, let's look at when there's a coefficient in front of the base. So 5x to the negative 6, we're going to write this with a positive index. 5 multiplied by x to the power negative 6 really is what this means if I was to write it in expanded form. We wouldn't expect you to write that line, but just for your understanding, 5 is a whole number and we're multiplying it by, this is going to become a fraction. So we end up, and whole numbers multiplied by a fraction belong on the numerator. So we're actually going to do 5 multiplied by 1 over x to the power 6 following this law, which tidies up to become 5 over x to the power 6. Now let's have a look at some further simplifying. So I'm going to run through 3 examples here, and there is always more than one way of doing it. The more index laws you learn, the more varying ways you can do doing it. But the main thing that all index laws need is for the basis to be the same for you to apply those laws. So looking at this one, both have the same base. I can use the multiplication law of indices, which means I add the powers. So 3 plus negative 8 is 3 to the negative 5. need to write it as a positive power, so following this rule, it becomes 1 over 3 to the power 5. Over here, I've got two bases to deal with, x and y. I have coefficients as well. So I'm going to multiply the coefficients together, and I'm going to try and simplify it as much as I can using the multiplication law. So 3 times 5 is 15. Add the power. This is a power 1, remember? So we've got negative 2 plus 1, because this is the base of x. That's the power of x with the base x. Negative 2 plus 1 is x to the negative 1. And y, negative 3 plus negative 4 is y to the negative 7. Now I'm left to simplify this. Remember, in our heads, this is the same as 15 multiplied by x to the negative 1, which is a fraction, multiplied by y to the negative 7, which is also a fraction. So the 15 is on the numerator as it's a whole number, and these are on the denominator with their powers. So we get 15 over x to the power 1, which we just write as x, times y to the power 7. And then what do you do when the negative is already on the denominator? Well, what that means, a couple of ways of looking at it. I could use the division law, which I'm going to do, which means I subtract them and then I'm going to simplify later to a positive power. But it's not the only way you can do it. You can say that that's a fraction and automatically move any negative powers onto the numerator, which then means you use the multiplication law. So I'm going to use the division law. So 2 minus 5, because remember we take away the index, is 2 plus 5, which is t to the power 7. And that is simply how you simplify.